look at the sum and difference identities. I did break this up into a separate video just to help with the time. If I want to find the exact value of an expression, I can use the sum and difference angles because remember, we only have exact values at 30, 60, 45, and 90. And then the reference angles that are equivalent to it. But what if I considered writing 75 as the sum of 30 and 45? The 30 and the 45 I have exact values for, so I can apply the sum formula found in the textbook that you will need to add to your formula sheet. So the cosine of A plus B is the cosine of A times the cosine of B minus the sine of A times the sine of B. So what I've done here is I've replaced 30 and 45 as my A and my B value. Once I do that, I can distribute the negative through, and then I can replace it with the exact values from the trig chart that you are allowed to use in your assessments. I'm going to use some algebra to simplify it, and this is my final exact answer in blue. So when we're working with the sum and difference formulas, we're really just trying to use those perfect values within our trig chart so that we can get an exact value. Now, when they have something like 17 pi over 12, that may be kind of hard to work with. So what I would suggest is actually converting that over to degrees and then working with it from the angle of degrees. If you do that, you should notice that pi over 6 is going to be a perfect thing, and so is 5 pi over 4. So that if I have the sum, I'm going to do cosine A, cosine B, minus sine A, sine B. I'm going to plug in my exact values for those angles, and I'm going to simplify with algebra. So the key here is knowing the formula, but also being able to break apart an angle into the sum of two angles we know the reference value for. I can also do it in reverse. So here I can recognize that I have cosine A, cosine B, plus sine A plus sine B, sine A times sine B. So in that case, that is the cosine of A minus B. So if I do 173 minus 83, that's the cosine of 90, which brings my final answer to 0. So you should be able to recognize the formula frontwards as well as backwards. Now, if I want to find the angle that satisfies each of those, I know that secant and cosecant have a unique relationship. I know that they're equal when I have 90 minus theta, so I can convert one to the other. When I do that, I will find that cosecant would be 62 degrees applying that fundamental theorem. The same occurs here, so I'm going to do 90 minus 62, which is 28, so that is the angle that satisfies it. If I do tangent theta equals cotangent of negative 54, and I'm trying to find that value for theta, I know that tangent is cotangent of 90 minus theta. So I'm going to say, well, what is 90 minus theta equals to negative 54? What is the answer to that question? And it's going to be 90 minus theta equals 54, setting those insides equal to get 144 degrees as my theta. Here with the cosine, I'm going to relate them again so that I get my final answer that theta has to be 7 pi over 6. If I want to find the exact value of an expression given an angle, I'm going to think about how can I make 15 out of those exact reference values. Well, 15 is 30 minus 45, so I'm going to apply the difference formula for sine, which is sine A cosine B minus cosine A sine B. Then I'm going to replace it with the values from my trig chart, and I'm going to simplify it down to a final answer. If you're not good with working in radians, you might want to convert this over to degrees before you start, and then work from it in degree format. If you did leave it in terms of radians, this would be the tangent sum, which we would plug into the tangent sum formula, which is tangent A tangent B over 1 minus tangent A times tangent B. Then we're going to replace with those nice values from our chart and get a final answer. I'm going to use a conjugate because I can't have a radical in the denominator. The lab will not accept it. So that when I multiply, I have the difference of squares, and I'm going to fully simplify it out. And I can only go down to 2 minus the square root of 43 because every single value has a 2 in common. Here is another example. This time, instead of going directly from the tangent equation, I'm having to move it over into the actual equation. So I'm going to get tangent of 100 minus 70 is 30 degrees. Now that subtraction symbol at the top should be multiplication. That is a typo on my part. So it should be tangent of 100 times tangent of 70. So if I want to write cosine of theta minus 270, I'm going to rewrite that using this difference formula for cosine. Then I'm going to work on finding what is the value of cosine 270, what is the value of sine 270, so that I know that I would get negative sine theta. If I have tangent of theta plus 3 pi, I'm going to apply the formula, and I'm going to simplify it down to tangent theta. Because 1 minus tangent theta would be tangent theta times 0. If I want to simplify the sine out to the sum, I'm going to apply the formula. I'm going to get it as simplified as I can. I still don't know theta, and that's okay. Once we start moving into positions in the coordinate plane, that's going to affect the sign of your final answer. So if I want to identify the sign of A minus B, but I'm given a specific quadrant, then I've got to make sure that I'm utilizing the information. In quadrant 3, sine of A is negative and tangent of A is positive. So that's why it's going to be really important that you pay attention to what quadrant you're in, and then based on that, you make the correct assumptions. So to find sine A and cosine B, we're going to work off of that fundamental identity, and we're going to solve it for sine. Then we're going to plug in to get our final answer of negative 24 over 25. We would do the same thing with cosine. Plug it in to get an answer of 4 over 5. Then I would plug in the values for A and B so that I have them. So then I would plug in the cosine of A and the sine of B and so on. Here, if I know tangent A and tangent B, I can use my identity to take those values I just found, divide them, and get 27 over 4. I can do the same thing with angle B to get negative 3 over 4. Utilizing that difference identity, I can then find tangent of A minus B, which is going to be negative 117 over 44. The only quadrant which is going to satisfy both of these qualifiers is going to be quadrant 4. So that's how we know where they would be located, where sine is less than 0 and tangent is also less than 0. And that is going to conclude our lecture for the sum and difference. There are some sample equations that we can go through, and there are also some word problems. If you encounter difficulty with those, just be sure to reach out to me.